In this video, we shall be treating a case on method of moment estimation. And we are given this. We are asked to derive the method of moment estimation for theta, given this PDF. That means probability density function. Solution. For more on this topic, you need to subscribe to this channel. So we are given the PDF f of x theta to be equal to 2x all over theta squared. So from the method of moment estimation, we take the first moment. So we write for the first moment. For the first moment, our population mean is equal to our sample mean for the first moment. So we'll come here. What is the population mean and what is the sample mean? So to get the solution for the method of moments, we need to equate these two things. First, the population mean is equal to the expected value of x. While for the sample mean of the first moment is equal to 1 all over n summation as I running from 1 to n xi. This thing is the same thing as what we call the mean. So this is it. Now, what is this? This is also equal to, since we have this as our PDF, we have it as the integral from 0 to theta x multiplied by the given PDF, then dx. So we have to find this. When we find this, we will now equate it with what we have here. That means we find the population mean. We've already looked for the sample mean, which is x bar, which is our mean. So what is the population mean? Now, it then means that we'll look for what the expected value of x is. We said the expected value of x is equal to the integral from 0 to theta x multiplied by the PDF dx, which is equal to the integral from 0 to theta x multiplied by what do we have as our PDF. Our PDF is 2x all over theta squared. 2x all over theta squared. So we multiply it with 2x all over theta squared dx. Is also equal to, we can bring out the constant, which is 2 theta squared integral from 0 to theta x squared dx. So we can integrate this to give us 2 all over theta squared into, if we integrate this, we will have x3 all over 3, then 0 to theta. Of course, since this is integration, anywhere we see x, we put theta. For the first time, we will now subtract it with 0, because if we put 0 into x, everything here turns to 0. So it's also equal to 2 theta squared multiplied by theta cubed all over 3 minus 0. This is what we get. So of course, this is multiplication. We can write this as 2 theta raised to the power of 3 all over 3 theta squared. Of course, the whole of this will cancel this. So we'll have 2 theta all over 3. It then means that our expected value of x is equal to 2 theta all over 3. That means we can write it here as this to be equal to 2 theta all over 3. Now, The next thing to do is to equate the population mean to the sample mean. So we write equate the population mean to the sample mean. So we have to equate these two things, then find our estimate, which is theta. So we move over to this other side of the board. We move over to this side. For more on this topic, you need to subscribe to this channel. So since we say equate the population mean to the sample mean, it then means that we just simply say we should equate these two. This is the population mean and this is the sample mean. So what did we get as the population mean? We got 2 theta all over 3. What did we get as the sample mean? The population mean we got 2 theta all over 3. For the sample mean, we got x bar. So we have x bar. Now we say solve for theta. To solve for theta, we just make theta the subject. If we make theta the subject, we have 3x bar all over 2. It then means that our theta estimate is equal to 3 all over 2 x bar. So we have succeeded in finding the estimate of theta. So the estimate of theta is 3 all over 2 x bar. For more on this topic, you need to subscribe to this channel. From the given question for the method of moment, we can show if theta estimate is unbiased for theta. Yes, we can determine or we show if theta estimate is unbiased for the given value, which is 2 over 3 x. So we should recall that x bar is equal to 1 all over n summation of xi as I running from 1 to n. And we should also note that the value we got for our theta estimate is 3 all over 2 x bar. We also note that what we got for the expected value of x bar, what we got for the expected value of x bar is 2 theta all over 3. So how can we show or how can we determine if the estimator, which is this theta we got, how can we determine if it is biased or unbiased? So this brings us to unbiasedness. It then means that we are to show that the expectation of theta estimate is equal to theta. But first, let's go through this. We can recall that the expectation of x bar is equal to the expectation of 1 all over n summation of I running from 1 to n xi, which is the same thing as 1 all over n summation of the expectation of xi as I running from 1 to n. Of course, if we sum a constant, we get n. So we have here to be equal to 1 all over n multiplied by n multiplied by what we got as our expected value of xi. So what we got as our expected value of x is 2 theta all over 3. So if this n cancel this n, we'll get 2 theta all over 3 as our expected value, sorry, of x bar, as our expected value of x bar. Now, we are also to check the expectation of theta bar to give us theta. If we can show this, then it means that the estimator is unbiased. So we move over to this other side. So we recall that the expectation of theta bar, sorry, is equal to, now we'll ask ourselves, what did we get as our theta bar? What is our theta bar? So our theta bar is equal to the expectation, nothing has changed. What is our theta bar? Our theta bar is 3 all over 2 x bar. Our theta estimate is 3 all over 2 x bar, which is the same thing as, we bring out the constant. So we'll have 3 all over 2, then expectation of x bar. Now we'll ask ourselves, what is x bar? What is x bar? Our x bar is 2 theta all over 3. So we have it to be equal to 3 all over 2. What is expectation of x bar? Expectation of x bar is 2 theta all over 3. So we have multiplied by 2 theta all over 3. Of course, this will cancel this and this will cancel this, which gives us theta. So it then means that the expected value of theta estimate is equal to theta. So since our expected value of theta estimate is equal to theta, it then means that the estimator for this is unbiased. So we write, since our expectation for theta estimate is equal to theta, it means that the estimator of theta equal to 3 all over 2 x bar, sorry, x is unbiased. So this is how to show or to determine unbiasedness of an estimator. For more on this topic, you need to subscribe to this channel.